This is an instructional video on using the Pythagorean theorem to solve word problems. So when you have a word problem, you need to draw and label the shape described in the word problem. Typically, this will result in a right triangle because that's the Pythagorean theorem, but not always. So read the problem carefully, draw and label that shape. You're going to use the Pythagorean theorem to solve it. The most important thing is that you answer the question. Being a word problem, there will be a specific question asked. Make sure you go back and have answered the question from the word problem. A rectangular pool at Andy's gym measures 25 meters by 50 meters. How many meters would Andy need to swim in order to swim diagonally across the pool? So it tells me a rectangular pool. So that tells me to draw a rectangle. It tells me that they measure 25 by 50. And the question is, how many meters would Andy need to swim in order to go diagonally across? So I'm going to draw my diagonal line. We label the 25 and the 50 meters. We drew the rectangle. We drew the diagonal. From here, we can use the Pythagorean theorem, a squared plus b squared equals c squared, to solve it. Remember, a and b are your legs, c is your diagonal line. So a is going to be 25, b is going to be 50, and c is unknown. 25 squared is going to give us 625. 50 squared is going to give us 2,500. Add those together is 3125. Remember, the last step of the Pythagorean theorem is to take the square root. And we get an answer of 55.9. So our diagonal line is 55.9 meters. We're talking about meters in this problem. A pole vaulter rested a 17-foot pole against a wall. If the top of the pole hit the wall 14 feet above the ground, how far from the wall is the bottom of the pole? So for this problem, I have the ground. We're talking about that, so that's the flat line. And we have a wall going straight up. Looking at this shape from the ground and the wall, we have the pole going diagonally across. Typically, if you have the bottom section of a right triangle, you will have the diagonal as well, which is going, in this case, to be the pole. It tells us that the pole is 17 feet and that the wall is 14 feet, meaning the ground is missing. We know that the edges of the right triangle are A and B, the legs. The diagonal line is C, the hypotenuse. Using that information, once we have drawn and labeled the triangle, we can plug in the information. A, the ground is missing. B, the wall is 14. C, the pole is 17. 14 squared is going to give us 196. 17 squared is going to give us 289. To combine like terms, 196 and 289 are on opposite sides, so we do the opposite operation. We do a minus 196. 289 minus 196 is going to give us 93. Last step of the Pythagorean theorem is to take the square root. The square root of 93 is going to give us 9.6. It's actually 9.64. But remember, for and less, we round down, so 9.6. To be more specific, it is 9.6 feet. For this problem, it says, what is the area of the largest square? Remember, area is multiplied by doing the length times the width. So for example, this small square here, if the area is 36, we got that by doing 6 times 6. With our area being 64, that would be 8 times 8. Those are our numbers that we use because there's 6 on each side, 6, 6, and 6, and 8, 8, and 8 for the medium square. So using the Pythagorean theorem, we use those two values, 6 and 8. 6 squared is going to give us 36. 8 squared is going to give us 64. 36 plus 64 is 100. Last step of the Pythagorean theorem is to take the square root. Square root of 100 is 10. Meaning our answer is 10. That's our length for our diagonal. That is not our area. Area is length times width. We have 10 all the way around, so we go 10 times 10. Area is length times width. Area is 10 times 10. The area is 100 square units. That's what I mean when I say make sure you answer the question. We did not stop with our answer, C equals 10. We had to solve a step further to get the area 100. If the area of square 1 is 25 units and the area of square 2 is 16 units, what is the perimeter of square 3? So remember, area is length times width. So if the area is 25, that means we are multiplying 5 times 5, each edge, 5 times 5. For square 2, the area is 16. 16 is known as 4 times 4, so each edge is 4. We're going to use that information to solve for square 3. A squared plus B squared equals C squared. A is unknown, that's our side 3. B is 4. C is 5, the diagonal line. Since A is unknown, we can only solve the 4 squared, which is 16, and the 5 squared, which is 25. To combine like terms, we do the opposite operation. We do a minus 16. 25 minus 16 is going to give us 9. Last step of the Pythagorean theorem is to take the square root. We get A equals 3. Meaning 3, square 3, is 3, 3, and 3. The question specifically asks, what is the perimeter? Perimeter is when you add up all the edges. In this case, square 3, the perimeter is going to be 3 plus 3 plus 3 plus 3. 4 sides, all of them 3. 3 plus 3 plus 3 plus 3 is going to be 12. The perimeter is 12 units. Denise is using a ladder to clean the outside of her second-story windows. The ladder she is using is 24 feet long, and she puts the base of the ladder 13 feet away from the house in order to avoid her flower gardens. How high up or the side of her house does the ladder reach? Round to the nearest tenth if necessary. So we're talking about some flower gardens, so that would be on the bottom. We're talking about some windows that are going to be on the wall. And we have a ladder. A ladder leaning is always the diagonal. Looking at the information, it tells us the ladder is 24 feet long. The base of the ladder, that's the bottom, is 13 feet away. So that's down by the flower gardens. We do not know how high up the side of the house the ladder reaches. We're missing the wall, the windows. And so we can make sure that we label them A for the flower gardens, B for the windows, C our diagonal for the ladder. And we plug those numbers in to the Pythagorean theorem. A is going to be 13, B is unknown, C, our ladder, is 24. 13 squared is going to give us 169. 24 squared is going to give us 576. To combine like terms, 169 and 576 are on opposite sides, so we do the opposite operation. We do a minus 169, and we get a 407. Our last step is to take the square root of 407, which is going to give us 20.17. 5 and higher, we round up, so that becomes a 20.2. 20.2 specifically feet. Will ran the diagonal distance across a square field measuring 40 yards on each side. James ran the diagonal distance across a rectangular field with a length of 25 yards and a width of 35 yards. Who ran a longer distance, and how much longer did he run? Show work to prove your answer. So we're going to start with Will. Will has a square. That's what it tells us. Each one being 40 yards. So 40 and 40. And we have our diagonal line because he ran the diagonal distance. For our Pythagorean theorem, we are missing the diagonal line. The diagonal line is C. So 40 squared plus 40 squared, which is going to give us 1600 both times. We add those together and get 3200. Our last step of the Pythagorean theorem is to take the square root. We get an answer of 56.56, which rounds up. 5 and higher, it's a 6. 5 and higher rounds up. So 56.6 yards. So that's Will's distance, 56.6. Now to do James's distance. For James, it says that he has a rectangular field. So we draw a rectangle. We label it the 25 yards and the 35 yards. And he also runs the diagonal distance. We're going to use the Pythagorean theorem. We're missing the diagonal line, which is letter C, the hypotenuse. 25 squared is going to give us 625. 35 squared is going to give us 1225. Add those together, and we get 1850. Last step of the Pythagorean theorem is to take the square root, and we get an answer of 43.01. 4 and less, we round down, 43.0 yards. Now we can actually answer the question. The question asks, who ran a longer distance? We can say, Will ran a longer distance. We can clearly see that in our answer. Will ran 56.6, James ran 43. The second part to that question, how much longer did he run? We have to subtract those two, 56.6 minus James's 43.0. Will ran 13.6 yards longer. When we subtract, we get an answer of 13.6. Make sure you answer the question from the word problem. Who ran a longer distance? Will ran a longer distance. How much longer did he run? 13.6 yards longer. Bethany has a circular tabletop that she needs to carry inside her house to paint. Her front door is a rectangle and has a width of 36 inches and a height of 80 inches. If the tabletop has a diameter of 86 inches, will it fit through her front door? So we're starting with the circular table. The circular table has a diameter of 86 inches. Diameter means all the way across. It's 86 inches long. Now, we also have a rectangle door. So there's my door. We have a width of 36 inches and a height of 80 inches. When we take the table in, it will not fit top to bottom. 80 is smaller than the 86. But we can solve the diagonal. We can turn the table in diagonally. To find a diagonal line, we use the Pythagorean theorem, a squared plus b squared equals c squared. We're missing the diagonal of the door. The diagonal is always letter C. 36 and 80 are our legs, A and B. 36 squared is going to give us 1296. 80 squared is going to give us 6400. Add those together to get 7696. Last step of the Pythagorean theorem is to take the square root, and we get 87.72. 4 and less rounds down, 87.7 inches. 87.7 is greater than the 86 for the table. So to answer the question, will it fit through her front door? Yes. The table will fit through the door. To walk to her friend's house, Julie normally walks 36 yards north and 16 yards east as shown. And I'm going to show you here in just a minute what that's going to look like. How many yards shorter would it be if Julie took the diagonal shortcut X? So when we are going north or south, east, and west, we need to have a compass drawn. On a compass, north and south are up and down. East is to the right, west is to the left. Now, we can draw it based on what she does. So 63 yards north, that's going to be 63 going up. 16 yards east, east is to the right, so 16 east. And then we want to have a diagonal shortcut. To find the diagonal of a right triangle, we use the Pythagorean theorem. 16 and 63 are the legs, A and B. We're missing the diagonal C, the hypotenuse. 16 squared gives us 256. 63 squared gives us 3969. Add those together, and we get 4225. Last step of the Pythagorean theorem is to take the square root. The square root of 4225 is 65. We are not finished. The question asks how many yards shorter would it be if Julie took the diagonal. It does not ask us how long the diagonal is. It asks us how much shorter would it be. We know Julie is going 63 north and 16 east. 63 and 16 is going to be a total of 79. Julie's walking 79 yards. If she took the shortcut 65, we subtract. 79 minus 65 is going to give us 14. It would be 14 yards shorter. Lincoln is building a wooden garage door in the shape of a rectangle with the width of 16 feet and a height of 8 feet. Lincoln is going to place 2 boards in the shape of an X on the door. How many feet of materials will he need for the X? So it gives us the rectangle. We can go ahead and label the rectangle with a width of 16 feet and a height of 8 feet. And you notice that the diagonal lines here that represent the X are our hypotenuse. We have 2 of them, so we have to do it 2 times. A squared plus b squared equals c squared. The Pythagorean theorem is what is used to find a diagonal line. 8 and 16 are our legs, A and B, because the diagonal line, the hypotenuse, is always C. 8 squared is going to give us 64. 16 squared is 256. Add those together and we get 320. Last step of the Pythagorean theorem is to take the square root. And we get 17.88. 5 and higher, we round up, 17.9 yards. But we are not done. 17.9 yards is for one diagonal. We have 2 diagonal lines to make an X, so we have to do it twice. 17.9 and 17.9 is going to give us 35.8 yards total. Make sure you answer the question specific to the word problems. We want how many feet of materials are needed for the X. The X is 2 diagonal lines.